Cooperation. You know, it's one of the biggest puzzles in all of nature. I mean, it's everywhere, from the cells in our bodies to, well, the entire society we live in. But how does it really work, especially when you have to take a risk? Today, we're going to dive into some seriously cool research that used rats, of all things, to get to the bottom of the hidden chemistry of teamwork.
So let's just start with the biggest question right off the bat. Why would you ever help someone if you get nothing back right away? Think about it. You have to trust that they'll return the favor down the line. It's a total gamble, isn't it? You could get burned. And that exact tension is what makes cooperation so tricky and so fascinating.
Okay, so in the animal kingdom, cooperation usually comes in two flavors. First, you've got immediate mutualism. This is the easy stuff. You scratch my back, I scratch yours, at the exact same time. The risk is super low because everyone wins right now. But then there's delayed reciprocity. This is the real high-stakes game. I help you now, and I just have to hope you'll help me later. It requires trust, and it opens up this huge risk of being cheated.
And that risk? It's got a name: the free rider problem. A free rider is that individual who just takes and takes and takes, but never gives back. They get all the sweet benefits of teamwork without ever paying the price. Honestly, this is the single biggest hurdle that makes true, trusting cooperation so hard to pull off.
So how in the world do you design a test for real trust? Not just that simple, we both get a prize stuff. Well, a team of researchers came up with a really clever experiment to figure it out.
Their goal, which they published in Science Bulletin, was to build a task with a very specific pay first, reward later structure. This setup forces one animal to help its partner first without getting anything back immediately. They're basically banking on the idea that their partner will do the same for them down the road.
Okay, so picture this. You've got two rats in side-by-side chambers. To get a reward, they both have to poke a little port at almost the exact same time, within a 1-second window. But here's the kicker. Only one of them gets the water reward, and who gets it is totally random. So, a rat who just got a drink has absolutely no immediate reason to help its partner on the next round. It's an act of pure faith.
This setup is just perfect, right? It really forces a choice. Are the rats going to keep helping each other out even when it's not their turn to get a reward? Or are they going to turn into free riders and only bother when they're thirsty? What do you think happened?
All right, so what did they actually find? Well, the results were, frankly, pretty incredible.
According to the study, the rats showed robust, direct reciprocity. And what that means in plain English is that they weren't just acting together for a quick shared prize. No, they actually learned the pay-it-forward system. They consistently helped their partners, trusting that the favor would be returned.
But, and this is where it gets really interesting, there was a twist. The scientists started to notice that the quality of the social interaction between the rats mattered a lot. Pairs that seemed to have richer interactions learned to cooperate way faster and were way more successful. So of course, they had to put that idea to the test.
So to test this, they put up a clear barrier between the rats. Now they could still see each other, but it really dampened their ability to interact socially. No sniffing, no touching. And the result? Whoa. Cooperation rates absolutely plummeted. That tells you that the social bond itself wasn't just a side effect, it was a key ingredient.
So, if it's not just about a simple reward, what's really going on inside their heads? What's the internal mechanism that's driving this incredibly cooperative behavior?
The study points to a really powerful biological driver, oxytocin-mediated empathy. Now, you've probably heard of oxytocin. It's often called the love hormone or the cuddle hormone, and it's a huge player in social bonding. What the researchers are suggesting is that this chemical actually promotes a kind of empathy that makes the rats just, well, less likely to cheat on their friends.
This is a pretty big deal, because for a long time, a lot of theories about cooperation were focused on external things, like punishing the cheaters. But this research shines a light on a powerful internal force, an empathetic drive that actually makes cooperating feel rewarding all by itself.
Okay, so let's zoom out. We've been talking about rats, but what does this chemical code for teamwork have to do with our own, much more complicated social lives?
Well, when you start to connect the dots, a really fascinating picture emerges. The rat study gives us this biological engine for teamwork, this oxytocin-driven empathy. And that mirrors so much of what we know about human psychology. For example, self-determination theory tells us that our need to feel connected to others, our need for relatedness, isn't just a bonus, it's a fundamental psychological need. And then you've got the famous triangular theory of love, which identifies intimacy, that feeling of closeness and being bonded, as the absolute core of any strong, loving relationship.
So what this all suggests is pretty profound. It means that the same basic biological wiring that encourages one rat to help another might just be the very foundation upon which we build our most meaningful human connections, our friendships, our families, our romances. The chemistry of teamwork, it turns out, might just be the chemistry of love itself.
And that leaves us with one last big question. If this empathetic, cooperative drive is so deeply hardwired into us and other mammals, then what is it about our modern world, our societies, maybe even ourselves, that sometimes gets in the way? That's definitely something to think about.